We've talked a little bit about distributions, and we're going to build up today to the difference between empirical and theoretical distributions. This is important because it's one of the fundamental ideas behind a p-value. So a p-value is the probability of observing a test statistic of a given magnitude or larger remember this part, if the null hypothesis is true. And today we're going to talk a little bit about what would things look like if this null hypothesis were true. We're going to distinguish between empirical and theoretical distributions. Remember, a distribution simply shows the spread of the population or the sample that you have, or it can also be the idea of what's the probability of getting people who are within certain values. Empirical distributions are things that we go out and measure. We might take a survey of people. We might have a census of income, for example. We might do an experiment. Or you might have a distribution of, say, the CDC growth chart, which shows kids and how fast that they grow. When you have an empirical distribution, you can usually tell because they look sort of chunky like this. They don't look neat. They're not perfect. You might have some gaps in here or some spaces and so on. A theoretical distribution is drawn from a formula or an equation. We're going to see some of these soon, such as the normal distribution, the T distribution, the F distribution, and so on. These are going to be used when we take our statistics, the data we get when we do a study, and then we try to reference them inside one of these distributions. This will allow us to say, what's the probability of getting our data if the null hypothesis is true? Let's talk first about empirical distributions. There's a cool figure that a student sent me. This was in the New York Times, and it shows how many calories are in a meal from Chipotle. So they went through Chipotle and they looked at all the orders that people had given, and they looked at the distribution of those meals. And you can sort of see there's a peak sort of here. This would be the mode. What is the most commonly ordered, the most common number of calories for orders there? And that's somewhere around 900 to 1,000. And then you see there's this little bump right here. This is super cool. That you might say, is this an artifact of the data? Is this just random noise? But that's actually real. That's when you ask for sour cream or guacamole, and you get that little bump. And then they draw this little reference line here. The RDA for the average American is around 2,000 calories. And you see all of these single meals that are more than 2,000 calories. So this is an empirical distribution that comes from actual real data. And we also see a similar distribution for the amount of salt in each order, and then the amount of saturated fat in each order. You might be tempted to sort of draw some shape on these and see some sort of pattern, and we'll talk about that at the end of these slides. Here's another cool example of an empirical distribution. These are data that come from how much kids sleep. So this top figure right here, this A, is weekday total sleep in kids. And the way you can read this is, let's say we're talking about a 16-year-old. You can go here to age 16, and you can look at the 50th percentile or the median, and that tells you that the average 16-year-old sleeps about, something about 8.5 hours per day. But there's a distribution around that. There's some spread around it. And this figure is really nice. It's these blue lines that you see here and here are the 25th and the 75th percentile. And if you remember, that's the idea of a box plot. So we could take 16-year-olds and sort of make a little box right there. And then in this figure, they also show those gray lines are the 10th and the 90th percentile. So we could sort of draw some sort of whisker. And at that, we could see for 16-year-olds, this shows the distribution or the pattern, the variability in how much they sleep. So if you go up to the 90th percentile, you get somewhere around, 11 hours or something like that. And that means 10% of kids sleep more than 11 hours. I almost said per night, but it's not per night, it's per day. This actually includes naps, which is an important source of sleep for 16-year-olds. So these are some examples of empirical distributions. Now, we're going to start seeing that there's patterns that show up again and again when we look at empirical distributions. And one of them is this idea of a normal distribution. So take your head, tilt it all the way to the right, and I can draw a shape that looks sort of like this, some sort of normal curve. When you take people and you measure them on something that is driven by biological processes, we start to see the same pattern emerge again and again. You see examples like this in all old statistic books where they take high school kids or college kids and they have them line up in the bleachers, and you put all the short kids over here and all the tall kids over here. And when you line them up, look what you see. You see some sort of shape. It happens with boys. It happens with girls. And it even happens with, these are college students, sometime from the 70s, by the pants. And we see this same pattern emerging again and again. And we're going to see this has a special name. It's called the normal distribution. But here, these are just empirical distributions. These are things that are measured in actual people.